The coach of the cricket team buys 3 bats, 6 balls for rupees 3,900. So here we are looking at this is the first equation, right? This is the key part. So the first thing you have to do is mark the key part. When you're reading the question, it's important to understand keywords or key frame or sentence, all of this. Later, she buys another bat, another means single, and 2 more ball of the same kind for rupees 1,300. Represent this situation algebraically and graphically. So the very first thing is drawing. Draw the situation. It's a simple one, but still, I would like to do so. And we need to understand what is that we need to find. So we're looking at finding let x and y be cost of each bat and ball. So I'm considering bat as an hockey stick. So I know it's not a bad bat, but I would like to go with hockey stick. And then we have a ball. So we're looking at x and y over here, right? So now if I buy 3 of them, it will be 3x. Makes sense? Each of this is x, and so we have 3 of it. So we have 3x. 6 of it is 6y. And when you add them together, you have 1,300. That's my equation 1. So this person buys another bat. So the coach, she buys another bat. Another means one single bat plus 2 balls. So we have again 1,300. Here I made a mistake. This is 3,900. That's my equation 2. Now, to get any kind of graph, we need to express x or y in terms of y or x, right? So there are 2 parts to this question. One is to find a situation algebraically. So we found it. Then is to plot it. For plotting, again, we need to express x in terms of y, or if not, y in terms of x. So decide on what you want to go with. Well, it's very clear. 3 and 6. 3 is the least number and easy to handle. 2, 3 and all of this easy to handle. So what will I do is I will express x in terms of y. That is, I'll write from 1. We have 3x being equal to 3900 minus 6y. Then what we'll do is we'll divide with 3. So we have x is equal to 1300 minus 2y. Okay, we'll call this as equation A. Then we have from equation 2, quite simple. You can skip steps, no issues. So transpose it directly, 1300 minus 2y. So you can see this, both of this is showing you the same situation, right? Same expression, right? I reduced it. It's not that you have to exactly use the same value. You can always reduce it, not an issue. But yes, in this case, it happens to be the same value. We can't help it, right? So now we're looking at graph, order pair for graph, order pairs for plotting, right? We have equation A and we have another equation B. Then we're looking at x and y, x and y. So now we have to figure out x and y value. If I put x value to be 0, y is that. Quite simple. Now x value, I can go with some number like 1. It's not easy to plot, right? We have to be practical. So I'll go with 100 or 50 or so. So I can go with 100. Let's see what happens. 100 is easy to handle, right? So when we put 100, we have 200, we have 1000. And then we can put 50, which will make this 100. 2 into 50 is 100. And 1300 minus 100 is 1200. So since these two have the same expressions or equation, we can just copy. And now the next step is to plot. For that, I need the graph sheet. So we're looking at x and y axis. So again, it's not that I just drew this line. I could have drawn it as a center also. But why the left and why the left extreme? So if you look at the x values, they're all positive and they are in thousands, right? And I want a variation of hundreds. Okay. While y is 0, 50, and 100, that's not an issue. So the values goes like this, origin, and we have 100, 200, 300, 4, 5, 6, 7, 8, 9, and 1000. 1100, 1200, 1300. So we have 50, 100, 150, right? So this is my y, and that's my x, y dash, and x dash. The information for scale, we'll write it once we draw the graph itself. So let's have a look at the values. We have 1300, 0. So it's over here. Then we have 1100 and 100. So it's over here. And the third value is over there. So we have the graph to be looking like this. Again, it should be a straight single line, no overlapping lines. I happen to do that. I will always do that because, well, that's my restriction in using the software. So please don't do that. Okay. Then we have to mention about the scale. So since we have a lot of space, we can do so over here. Scale, we're talking about along the x-axis. 1 centimeter happens to be 100 unit. And y-axis, 1 centimeter is 50 unit. Right? So this is 200. So on and so forth. This is equation 1, and this is also happen to be equation 2. And we have our coordinates 100 comma, sorry, 1000 comma 100. Then this is 1100 comma 50, and this is 1300 comma 0. Okay, so we have our graph, right? So let's verify if we have done it right using our code. So this is our expression, right? So here I've expressed y in terms of x. Okay, because I've coded that way, wherein x is generated as a random set of points, and the values are put over here and plotted. So the system will do it automatically. We need not do anything regarding that. So here we have I'm asking you to plot from -100 to 1500 for a 600 value. Okay, this you'll understand in time. But yes, this is the limit. And once I plot it at the old, yeah, we got the graph. So we have 0 over here and 0. So setting the origin will not show the graph. So we need to zoom out. So yes, we have the graph. So you can see it's a similar graph, but yeah, values are not as detailed as ours, but yes, if you zoom in, yes, it will come out, the details will come out, but yeah, this is the graph. So we plot it right. Okay, done.